And we are back. That should be fine. And let me listen if the audio works. Okay, the audio quality is not perfect, but it's intelligible. There's a lot of ringing and the noise gate is audible. Let me try to tiny bit diminish the ringing this way by decreasing. I think I'll change the setup, the audio setup. The other one is a lot more cumbersome, but it works better than what I have now. But it's for the next episode. Audio works. That's good enough. Let's start and continue with the IOVoodoo, because as I promised, as soon as I receive the board, I will make the first prototype. And as you can see on the bench camera, I received the boards. But first, a quick overview about the IOVoodoo. So here, there's an introduction. Yeah, there's the overview of the whole project we've done since the beginning. We finished ordering, and now assembly and test ongoing. And this is what we do. And I will just assemble and test the hardware. The firmware is for the next part. But as soon as I'm able to program the firmware, then the stream is done for now. I need to tweak a bit the firmware to work on this board, because it only works on the evaluation board and not on this one. But if we see it, if we're able to program it, it's good enough for me. And I'll do a next stream with testing the firmware on it. For now, I'll just show you how I do hardware when I receive it. So this is the order. What we will do is we don't need this overview anymore. Instead, what's more important is having, now I need the schematic myself. I'll give you the schematic. I'll probably need more the parts. Not the way I wanted it. Let's go with schematic. Mute this audio. Schematic, here you are. So I'll give you the schematic. This we don't need anymore. Project is quite long, and that's the overview of the board. So it is a first prototype, and it's not like a production. It's not like a production board. We will do it step by step to figure out if I did the layout correctly and if everything works. First thing is opening up and have a visual check if there are some quality issues. Let's test it. Let's get a pair of scissors. There should be 5 boards. Yeah, you see my order number. So what the project is intended to be open source in the end. And yeah, I did 2 mistakes. I did 2 mistakes before ordering. I ordered too quickly. I changed it, and I did some change. And the one mistake I did is, but they fixed it. I've seen that they fixed it in the production file. Here, I've asked them to put the ordering number in under this connector. And I've just added the template to tell them, please put the order number. But while ordering, I didn't ask them to put here the ordering number. There was just the template on the sales screen. Well, they looked, so one human looked at it and saw that I've added the template. I just forgot to add things. So they added the number here. It is good. Is it good? Is it bad? In this case, it is good, but generally you don't want, if you don't ask for, when you order, if you don't ask to replace your sales screen with the ordering number, this is something bad. It's always a balance. In this case, they looked at it. Else the holes look nice, the solar mark looks nice. And all the vias are not tented. This is exactly what I wanted. So this is good. The vias are open. We can use it to test them. And so this is just 1 millimeter. And we can see that we have the two parts design on one board, but I've added here on the sides, here and here, I've added silk screen so we can actually know where to cut. There are two ways. There are actually plenty of ways to cut boards, and also this is just 1 millimeter board. It's not 1.6 millimeter. I don't need this huge, this really hefty board. 1 millimeter is good, and it allows us to cut easily. So the first mistake I did is here I forgot to ask them to replace the ordering number. They did. In my case, it's good. Generally, it means that they don't follow what you say while you're ordering. This worked. The silk screen is a bit small, but it worked. Version, distribution. Okay, this is hard to read. It was a lot easier to read on the thing. So next time I need to really increase the font. For now, for me it's good enough, but poof, it is rather small. So I will increase the font on the next production, and I'll know and increase it. And on the next one, I will have all these vias tinted, so there will be solder mask on it, and this allows me to write on the solder, and it eases a lot. So like here, they will be tinted also. The second thing I forgot here, this is the programming header. I forgot to add which pin is what on the programming header. And it is important because I don't want to check all the time. And we have the programming header here, and we can actually have a pen, and with the pen we can put the number. So here the square one is pin 1, and pin 1 is now that you see it, I don't see it. Let me open just something else so I can see it. Up. Check. So we have VBus 5V ground. Is it correct? This is VBus. Oh, I did a mistake on my silk screen. On my silk screen, sorry, on my board, because I fixed it afterwards in my in my board layout, but it is wrong in my board layout. So this is 5V. Then we have ground, and we clearly see it because we have thermals. So how do I know this is 5? So I know it is pin 1, and I know it is 5V because we have a thick trace going to the 5V. The next one I know it is ground because we have thermals. So this is this pen doesn't work correctly right now. This is ground. Next we have reset. Or if the pen work, it will be a bit better. After reset, we have the clock. So SVD clock, but we have enough space to put SVD clock, and then we have data input outputs. And there is an angle. Can I somehow not have you see? Yeah, this way. You are kind of an angle, but at least there is less reflection from my overhead lighting, and you are less in my way. So yeah, doesn't look good, but I mean, it's a prototype. It's fine enough. This is really just a prototype. Now, we have to separate the boards. We have 3 ways to do it, at least 3 ways to do it. We can actually use a cutter and scorch it, and then we can break it. Let me show you. I have 5 boards and I only need 1 of them. So why not show it to you? We need some flat ruler so we can scorch it correctly. And actually, like a pizza cutter would do it. Same way. And actually, I can use the opportunity to remove this branding. Out the almost not visible. Needs to dry before I can add a second layer. But yeah, with this branding it's not visible anymore. So, and I should do this on the cutting mat and not on my ESD mat. Let me get a cutting mat. Are we on the cutting mat? Just scorch it multiple times. You see there are already some part solder removing, and with the same here, kind of see. Did I ask? Yeah, I did. I should have added some silk screen also on this side this way, but it was not intended to do it with the cutter. I'm just showing it right now for the video, but it was not. Show you how else I do it. So it should be scored enough, and normally if it's scored enough by pressure, it should crack. That's not scored enough. We need to do it more. This side it should be enough, on the other side it's probably not enough. I don't know if it works also well with a pizza roller. Nice to try. That's scorched. On. What you can do is like with glass, when you're cutting glass, you just apply pressure here, but I hear it cracking. And slowly see it cracking. Should have scorched it the other way around. And that's how you can depenalize. That's one way to do it. It was not the intended way. The problem here is we have, this is really rough. And it's not nice to feel, so you can use some file and then file it down. Be aware of this fiberglass dust. So don't breathe in when you do it. And now the edge is smooth again. Let's do it on the other side. Doesn't take too long, and it removes the splinters at least. And there we have it. There we have a separation. But I didn't intend it to do it this way. Another way to do it is using, I think, metal. They're called metal scissors. It's something like this, and they are really it's meant to cut sheets of metal, and they're really powerful. Problem is they put kind of an angle when you cut the board. So on long boards it's not very beautiful. On short boards it works, and if you pay a bit of attention it works. This is the other way, and the way I intended it in the beginning is takes a bit of time. I have plenty of trash on the way to it. And it's huge. I don't know if it fits. It's using a guillotine cutter. So remove this. Let's check with one board. So we have one board. Let's check with the other, and with the other now we place it correctly. this way, and we can align. You don't see anything. Yeah. This is aligned to the edge. This is aligned to the edge. This is meant for paper normally, but it is really powerful and would work for 1mm board. It's also not an issue. So there we have it, and then we just press. It also puts it puts a tiny bit of bend because it's 1mm, but you can bend it back. But this way, the edge is quite it's okay. It's not perfect, but it's really okay, and it's really fast. So if you have plenty of panels, this is a good way to do it. Yeah, so guillotine cutter. Up. Let me put it back somewhere where it's not on the way, and then I have more space to work. And now we have two boards. This is the board I want because I marked which are where the pins are. So let's start populating it. So let's start heating up the soldering iron. Before I use the soldering iron, I want to check if there are some shorts on VCC. I can, instead of showing you the schematic, I will show you the multimeter. So I need to switch on the multimeter, and this I'm getting the multimeter ready. Serial not found. Why didn't you find a serial? Device. Inappropriate, no device found. No device found. This device. Check if on. There is a device, TTY USB 0 and TTY USB 1. Why don't you find it? Always debugging scripts. This one doesn't exist. Stat. It does exist. TTY USB 0. It points to it. Don't tell me that the Ruby script doesn't work anymore, because there is a Ruby pane, but yes, it points to this. USB 0. UI USB. I didn't look at the error, so you're not seeing what I'm doing right now because it's off screen. I'll show you if it doesn't work. Okay. Serial SP, device not found. Okay, but it's inappropriate call. Let me show you. Up, you see, if I open it, it says inappropriate call, and I'm pretty sure this is because there's some fucked up Ruby library. Jam install serial port. Please reinstall it. Building active extension. Okay. Okay, I have no idea. It never works. Okay. No, it doesn't work. I don't know why. SR. Oh no! No, that's SR, this is Sigrok. This is not Ruby. Sigrok is not able to open it. I have to reinstall Sigrok somehow. I don't know why it got broken. Which Sigrok did I install? I think it's this way to query it. And it's actually libsigrok. It's sigrok. So it wasn't my Ruby script. U big S. Sigrok CLI. Okay. Ah. Okay. It's a pain having to install everything. Sigrok CLI. Let's reinstall it if possible. Reinstalling. I'm sure it won't work again. I think libsigrok decode is responsible for it. Libsigrok decode is the library to open all the devices. Reinstall it. I'm sure it won't do shit. No. Serial libsp serial ports. Which library are you using? Inappropriate octal for device. If I cheat. And it won't work. And I forgot to install MQTT, undefined on escape for URI. Nothing works. I know what the issue here is. That's not here. Where is it? Ah. That's URI, it's CGI, and CGI. I need to push this. I need to open. Okay, it's not because of rights, and yeah, it shouldn't be because of rights because I'm in the right group. I just wanted to be sure. So yeah, I cannot show you the multimeter. I will show you the multimeter by hand because I don't know why libsigrok is broken. Yeah. Then we'll do it the old way. Can I read it another way? No, libsigrok is completely broken. Maybe, let me just... Sigrok minus S for scan. I don't remember how Sigrok works. Scan, yes. Minus scan. Yes, you found this one, okay. And you're not able to open. So, normally driver, that's the command. Dev TTY USB. If this doesn't work, USB 0, not USB 4. And just try to connect to its samples. Try to connect 5 samples. Okay, error opening port inappropriate octal. Okay, I don't know why. Why libserial is broken. Is it? What does it use? Let me check what Sigrok uses as serial. Packages. libcgrok decode. Which library does it use? It doesn't use any library. It uses the Python library. Weird. Python library broken. What is this? Is this a known issue? That doesn't seem to be a known issue. Ah. PySerial. Okay, PySerial. It seems to be a known issue from PySerial. I need to reinstall PySerial. Try that out. Python serial. What is PySerial? What is the package for PySerial? Python PySerial. Okay, PySerial. It's installed again. Let's try if it works now. No, it doesn't. And I don't want to debug it now. This is not the purpose of the stream, and I've spent already too much time. So there will be no multimeter view for you. I will just put the multimeter next to it, and we will check with the multimeter. So we'll have it the old-fashioned way. You won't have a dashboard. Old-fashioned way. Yeah, leading edge is unstable. So I want to measure the resistance between ground. This is all ground, and I think I've connected this to ground. Yeah. So the shield of the connector is connected to ground. And let's test with the 5 volts. Yeah. Over limit. It means that there is no short between plus and 5 volts. So this is a good start. Switch on the soldering iron. Put some water, and what I start is with the power domain. Once the power domain is enabled, I can check with the rest. And actually, what's good here, I do have a connector for all power domains, so we will put a connector here. Normally, you put the through-hole component at the very last, but this is if you do production. We don't do production, we do a prototyping, so we will add the header, not at last, but we will add it now so we can actually debug it. This is 5. I can cut it from my debugging headers. Here I have a row which is already cut. I need only 4. Let's get side cutter. This I don't need anymore. This goes in the trash. Side cutter. 3, 4. Up, and this allows us to connect easily multimeter leads or things like that. Actually, it's missing something. It's missing ground, but we can get ground from here, from any other pin. So we will also add this connector, so we can have ground. Will we? Will we? No, for now we don't. Up, solder. I use leaded solder because it's easier to solder, and for prototypes it's fine, it's not production. We will just solder one pin, down, up, then we place it as we wish it. Oh, I touched the pin which was getting hot. What about that? And we solder the rest. So soldering will probably not fun. We'll show you soldering. We'll see me soldering, but there will always be testing in between. So that's okay. Actually, we could, instead of Although no, here. Yeah. Up, up. This is done. Do we solder this connector also? We've already soldered one connector. Why not solder the other one? I don't have a lot of these connectors. I have only 10 of them, so the headers, I have plenty of them. The next part is soldering this USB. So, USB. Yeah. I have my USB book. This is my surface mount component book, and I know I need the 16-pin USB. This is micro B, this is micro B, this is C. We have 6-pin, this is the plug. Yeah, 16-pin. And we'll get one of the first ones. And it's this one. Up. And it's probably almost the hardest part. So this anymore. I don't need two. So this is an ESD mat, but normally when I do really sensitive electronics, I have an, why is it? I have also an ESD strap connected to ground. So whenever you see someone using an ESD strap without connecting it to ground, you know he has no idea how it works. Because there are some ESD straps with a resistor inside, it doesn't do shit. You have somehow, if you are connected to ESD, you have to dissipate it to some reference. And if there's just a resistor, you're the only reference, so you're not discharging. You need to be connected to ground. A ESD strap successfully connected, not connected to ground, is completely useless and shows you that you're working with an amateur. Up. Okay. I'm telling it because I've seen it, and it fits perfectly. See, the connector fits really nicely, and because we had, oh wow, I should have used even less than 1 millimeter. See, it will be not easy to solder on these pads. So the tabs are only 1 millimeter deep, and I've used 1 millimeter thick PCB, so I can have somehow access to it. There's not a lot of access to it though, but good enough. Because there are lots of pin, we will use some flux, and I have some RMA 223 flux, just generic thing, and I've used a clamp with a 3D printed device, so I can dispense the flux precisely without having to push myself on the plunger for the syringe. And whenever you do surface mount devices, having lots of flux is always good. And I will get also the board holder. This way we can have something stable and we can rotate it all the time. So this is my board holder. Let's hold the device. I put also it above the desk. Helps me soldering. Yeah. Okay. Helps you remove it quickly. So those flux flows nice. Pins have been soldered. And I like this bevel tip because it has kind of a solder reservoir. So it has issues soldering correctly. Okay, it looks nice from, yes, it looks nice. Try these two, you can soldering, and using the macro lens, you can probably even see it better than I do. With the guy, there's Then no, looks okay. So USB is soldered. And let's also solder. I like this PCB holder because through all devices it's really nice because you can flip it. And now let's solder the tabs for having really strong sounds. Oh, I should have tested the connector before. Yeah. Just put one, but I need to test the connector before I solder this because afterwards it will be a pain to fix if there is anything to fix. Okay. Seem to be any short. So just solder just one of them until we know that the 5 volt is going in there correctly. We can even test if there is a short using the multimeter in deep mode, continuity mode. Test if there is a short across 2 pins. And normally these two should be connected. It's connected, yes. Okay, this is normal. Normal. These are the two plus and minus pairs of the USB 2 data lines. Okay, looks okay. But this way because now we need to put this small capacitor. This is kind of a filtering capacitor, and then we have a fuse capacitor. We will need plenty of them. So I have capacitor box and the power. Yes, the power SMD book. Capacitor box with all the values I need, and we will need a lot of 100 microfarad, 100 nanofarad capacitors. And this is 05, and you see I have plenty of remainings from other projects which we need to use. And here, a bag of 100 nanofarads, 5CV. I don't know what it stands for. They should be fine. I don't know what the voltage is for this one. Not written. This is the temperature coefficient rating. This is the tolerance, and I don't know. This is just 5 volt capacitors. I think they're fine. I don't think they're just only 5 volt capacitors. I don't know that any 100 nanofarad capacitors are only rated 5 volts. 5 CV stands for. But let's connect solder 1 pin up. Then I need some tweezers. Why are they not this one? Yes, this one. Fine tweezers. Yeah. ESD tweezers. I don't know why ESD, because it doesn't build. I don't know if the coating does anything. I'm touching the ESD mat, so it should be fine regarding ESD. And how do I solder parts? Well, I put one point of solder. This allows me to come with the tweezers and the component and solder on it. That's one side. Then we need not really flat. Oh, wow! Yeah. The camera, it's really not easy. It's so far away from me. To have you watch. Okay, now too far away from me. Okay, that's one side. Then you solder the other side. And then again, because they're not a lot of solder on the first one, and it's old, you solder the first side. And the same, so this was, so P1 is this connector, C10 capacitor, then we have F1, which is the 500 milliamp fuse. So capacitor box, we will need it later on, quite soon. And then we have the voltage regulator, power thing, and I think I have fuses here. Yeah, these polyfuses. So get one of them up. Back. I've got it some solder on one side. And we can switch hands. I have solder both hands all the time. The other way is just to rotate solder. Up, it looks a bit lifted. Okay. And with that, we should have 5 volts. Not yet, actually. So this is USB-C. USB-C. If you connect it to a real USB-C port, you shouldn't have 5 volt going out. Now you can cheat. Do I have one of them here? Here I have a micro USB cable. The micro USB cable does deliver 5 volt all the time. So if I use a micro USB to USB-C adapter, I will have 5 volt on the output. If it would be a real USB-C, there would be 5 volt there. And we'll test if this is true. So it really depends how good your USB-C port complies to it. Before I do that, I want to test if there's a short between plus and ground. So multimeter, this is 5 volts, is ground. Nope, there's none. There's no short. So if I connect, and what we can do, the way I want to show that. Yeah, let's show you. What's useful to do is seeing how much power it draws. This way you know if there's a short or if there's something which is wrong. So we would use a USB multimeter or USB device. This one up, it's big enough so you can see. Let's switch to the mode where it shows we quit this menu. Quit. Okay. Up, biggest screen. Yeah. Now you can see how much it draws. Let's get the USB cable. Power only cable. Connected to the output. Connect this here adapter. And now if we connect it here, there should be no power draw and we should still have 5 volts on the board. And no power draw, which is good. There's no short, none at all. And then if we connect, we test with the multimeter. Put the multimeter so you can always see it. Volts. And we don't have too much of the glare. This way. And now we have ground here, and if we touch 5 volts, it should go through the 5 volts rail here, should go through the fuse, and we have no 5 volts. Oh, this is 5 volt, this is the target. 5.2 volts. Okay, you didn't see what I was doing. This way. between here and 5.2 volts. Knowing that I cannot use the normal IOVoodoo. But that's good. So the 5-volt line seems to work correctly. Now what we will do is, and yeah, let's connect it with real USB, real USB-C. And with real USB-C, there shouldn't be any 5-volt. So let me get a USB-C cable, which is somewhere here. This should be real USB-C, and I hope that it does that. This, well, it is connected to a USB-C port, but I don't know. It really doesn't provide 5-volt. So if we test it, and this ground, it does provide 5-volt. Okay, this should normally not happen. So it means that the USB-C port is providing 5-volt, although I'm not requesting 5-volt, because here you have these resistors here, R1 and R2 are pull-down resistors to ground to tell the USB-C port now you are connected to a device. It also allows you to test which side it is connected on, side A or side B, because you can connect it to both sides, but it tells you we are connected now. Now you can deliver 5-volt. Before that, it should not deliver. I don't know if it should not or it can not deliver 5-volts. But in this case, it does deliver 5-volts, although I didn't request for it, and there's no device connected. So yeah, this is not a complete. I have to. Can I show it to you somehow? How that this is true? Now you'll have to believe me. It's too cumbersome to test it. Although, because this USB cable doesn't work, I can show you using yeah, this USB. I wanted to test this USB port because it's really USB-C, but with, well, it was connected to a USB-C port, and I hoped that it didn't provide 5-volt if not requested, but it doesn't. So let's take the cable and let's get a USB power supply where this behavior is watchable. So I'll test it. This a cable, and I would love for these probes to be connected all the time. So this is, whoop, this guy doesn't fit inside. This is ground. This is voltage target. This is 5-volt. Love for you to hold. And normally I don't know if this C. Oh, it does output 5-volt, does it? So you see, this one doesn't provide. Yeah, I've connected a USB-C power supply right here, and this one doesn't provide the 5-volt on the output, although it is USB-C. You do have a 3.3-volt line here, but I have no 5-volt output. And if you don't believe me, I can also test it here. No 5-volt output, although we are connected to a USB-C charger. This is because we don't have these indication resistors. So let me solder them, and they are 5.1 kilo ohm resistance. So let's disconnect it while we solder it. These boards can go away. Up, resistors. I should have plenty of them here. This is my box of resistor 0603 serial. So and everything which is above 1 kilo ohm. I have another box like this with everything below 1 kilo ohm, and we will go out of the way, and we will use 5.1 kilo ohm. What is this? 22. This is 22 ohm. Oh, this is below 1 kilo ohm. Sorry. This is up to 1 kilo ohm. Wrong box. I showed it to you, but I didn't read it myself. We will need it at some time though. This is the right one. Yeah. Above 1 kilo ohm. Up. This we don't need anymore. USB-C we also don't need anymore. So let's put it to the other table. Here. Good. 5.1. And so we know that it belongs here. Let's put it here. We need 2 of them. And I have all the reels of thousands, and you pay $1, something like that. I think R1 and it looks like R1 and R2 are the 5.1, but we can check in the bill of material just to be sure. Bill of material R1, R2, 5.1 kilo. Yes, the right one. So there's already a tiny bit of solder here. For ground, tweezers. Put it. I almost lost it. Put it this way so it is readable. Up. Same with the other one. Lead, switch hands. Although wait, to switch hands we can. Okay. And now if we connect it, now we should see 5 volts coming in. So ground, this should be 5-volt pin. Volt coming in. This is how it should detect. Is weird. Why are my theory wrong? Is this not on? I on? See, no 5 volts. On target volts. Check. I don't have 5 volts coming. That is my charge on something. What is wrong? Ah, this should also be 5 volts. And if I use this one I should have 5 volts. We tested it. Here they're for sure 5 volts. And we see it's yes, 5.2. And you don't provide 5 volts. Is this really connected? It is connected. device works. -1.3 volts, -1. Oh, minus is okay. Switch delete. But there's something I don't understand now. What if I connect this USB power meter directly to it? Will it USB Type C? This one doesn't provide power. Switch it on. Oh, okay, it goes. Ah, the USB power supply goes to sleep after some time. It's not used. Yes. Ah, and if power is not requested, it goes to sleep. Now power is requested. Does it go to sleep after some time if no power is used? So we know that the power supply works. It can provide 5 volts. Let's try if it does provide 5 volts also to our board. 4 volts. Ah, what does 4 volts mean? 0 volts. I don't like this power supply. Should be no short. Should be fine. 0 volts. Oh no, does it provide 5 volts? But and this is why it's good to have a prototype. Are these two resistors connected? Yeah, they're connected to get something. Is in. Way. I don't know why it doesn't work. Read. Now we have 5 volts, but this is just because we have this one, which is providing the 5 volts. If I connect directly, I don't have 5 volts. So we'll have to check. Soldering point looks fine. Ah, I know what I can do to test it. My first design with USB-C, so 4 volts. Is there a drop somewhere? And then it switches off. There's no short normally between 5 volts and ground. Measure the resistance. Oh. Ah. Okay. My USB-C breakout boards. I did some work on USB-C, and I have some breakout boards where I can test the signals. So let's have one of the breakout boards. So these are just and this is, for example, something to test if it works. Here, open CC1, and here you see some of my configuration. So these are 2 breakout for USB-C, and one is female, so receptacle. One is male, or I don't know, plug. Right. So this is receptacle, this is plug, and these resistor combination provides some information. What does what mean? 51K CC1 a resistor pull. Okay. It should be 56K. I didn't have 56K, so I've added a 51K or 52K because this is the closest I had at hand. But I should have one which actually also pulls it low. Plenty of them. This is switched around. What is this one? 5K1 and okay, but this is plug. I need receptacle. Well, are they? Here. Yeah. This is receptacle where we have 5K1 on one side. And let's check if it provides 5 volts. 5 volts. Normally, if between ground, the ground which is not used, so V bus should be 5 volts. See anything? So I connected all the grounds together. So there are 4 ground points on a 24 pin. Now if I measure V bus, okay, I don't get 5 volt output. So there's something I didn't understand in USB-C. Because normally, if you do that, oh, I do get 5 volt output. Does it switch off after some time? Let's test. It does switch off. Okay, so it's a USB power supply which switches off after some time if there's no power usage. I do have another one. I don't know if this is standard compliant or not. I must read USB power supply, USB C spec again, but this is weird. Maybe it's just this one. Let's test another one. Smaller one. Up. Power delivery. Normally, if I connect just the receptacle without anything, we should have 5 volts on the breakout board. So ground is here, a V bus, there are 2 V bus. No, this is V bus. Yeah, we have some, yeah, it is pulse. There's some kind of tiny pulse, but this is not 5 volts. We plug this. Now we should have 5 volts on outputs. Dust, ground, V bus. No, we don't have 5 volts. Okay, so it's me not understanding something about USB-C. And the cable. Ground. Oh, we do have 5 volts. Ah, on one side, but not on the other? Did I measure it wrong? Ah, the cable doesn't have all the connections. That can be the case. Yes, if we use a cable on one side, we do have 5 volts. But not on the other side. So it means that this power supply doesn't check the direction of the cable, because it should, using the CC, it should know, okay, on the other side there is a resistor. I should still enable it. This is weird. Yes, I do have the cables. I do have 5 volt if I connected one side. And does it actually work also? Do I have 5 volt if I connected one side without the resistor? Ground. No. Okay, so we don't have 5 volt if we don't connect the resistor, which is for orientation. Ah, orientation, that was the word I was looking for. With the resistor, we do have 5 volts on one side, but on the other side, it should still know that this is just a reverse. There I have to read the spec again. Here we don't have 5 volt output, but we have the resistor on both sides, so it should provide 5 volts. Our device. Connect. Stack. Doesn't. Ah, I didn't touch the right pads. This pad and that should be 5 volts. Should be the raw 5 volts, and it does not work. although I have 5.1 on both sides. Flip it. Still does not work. I have no idea why. It is still 5.1. Let's try measure if it's 5.1. So we have here a part, the plug part. Let's measure the resistance between ground. Oh, did I do it correctly? Yes, between. Okay, this is flipped. So which one is CC? Yeah, 5.1. I test the other one. 5.1. I make the mistake twice. Is this really CC1? Okay, I'm not trusting this plug. I'm trusting this one. Tons of plugs. This one. Here. This thing. That's. I don't need to solder for now. So let's test with this real CC1 and CC2. Because I know I did a mistake on my breakout boards. Up. So this is ground. One that is. It doesn't tell which one. And CC1 is A5 or B5. Okay, on A5 there is no ground. I think the footprint is wrong. There's no 5.5 kilo ohm. B5. There is no 5.1 kilo ohm. Did I do something wrong in the footprint? Oh, I already see somewhere something weird. Is that on one side? This is weird. I think my footprint is wrong. Let's check the footprint. Screen. So the app, we are on the top side. So what I see wrong already, which I find really weird, is that here, because it is symmetric, here I have it next to the power directly, and here I have it next to the data line, which seems kind of wrong. So I think the footprint, this footprint is wrong. Yeah, first time I've used it. So let's check if this is the case. Hardware, data sheets, and it's this connector. Here we have the footprint. This is the bottom view. Oh no, it is right. B5 and A5. So this should be B5. is it called B5? So if I see correctly, this is flipped it. This is B5, this is A5. Yes, I mixed top view and bottom view. I switch in my head. This is B5. This is B5. This is A5. And if we look, R2, R1, where is sheets? Where is the schematic? Here, the schematic. Oh, actually, you don't see. Sorry, I didn't show you the right screen. Why didn't? Full screen. Yeah, full screen. So, what I found weird is that here we have one pin in between the power pads and the CC line, and here we have no pins. I found this weird, but it is actually fine. So this is for later. So this is the bump. This is actually fine because here you see we have no pins between B5 and power pin. Here we have one pin between A5 and the power pin. And A5 and B5, you see A5 and B5 are the CC lines. And this is where we need to lower up. But what I didn't pay attention to is this is the bottom view. I pay attention when it is written bottom view. Here it is not written bottom view, but it is kind of, now I see it. And it means that this B5 should be this B5. And yeah, this is wrong because I've connected it here. At the pin number 6 connected to R1. Pin number 6 is CC1. I've sold it. One A5. Yeah, I flipped it. This number 6, and it is not CC5. A5. This is pin number 6, and this is 5. So yeah, the footprint is wrong. It's really easy to fix. For the schematic, and this is why it is really good to have a prototype. And it is fixable, and we can fix it on the board. We just have to patch some wires. And I think this is SBU. What is on these pins? Can I short them if I don't use them? I think these are sideband use. B8 sideband use. Yes, I think I can just short them. I don't use the sidebands at all, and I don't think it is important if they are shorted. So, yep, good that we have a prototype. Let's just short the two pads with lots of solder, a solder bridge, solder. Come on, create a bridge. This is something normally you don't want. Now I want it. Okay, now it's too much of a bridge. The flux. But yeah, the flux will remove the bridge. Do I use dip alcohol to remove the flux? Flux is preventing me from creating a bridge. Did I flip? Did I flip D plus and D minus? This is completely understandable. I did. So which are D plus and D minus? A6. Do I want to fix it, or do I want to order a new board? Takes 2 weeks to order a new board. I only have one microcontroller, that's the issue. And I don't want to solder this microcontroller and then remove the solder. Okay, let's test if this is spare board. Okay, let's test it. If D plus and D minus are switched, so A6 and A7. 6, A7. Yes, they are switched. Okay, so, and A6, A7, yeah. Okay, so this is junk. This prototype is broken. Even so, let's still make the bridge and see if we have 5 volts. Here, D plus and D minus are broken, so we could actually fix here and have them swapped, but it doesn't look nice. I have 2 issues. I have an issue with the connector. So let's make at least the solder bridge to see if this works. A bit too big to create a bridge. Check your footprints. What is good is that the dimensions are correct. At least I got this right. Okay. We have a solder bridge on the first one. Okay, solder bridge on 2 of them. Let me show you. See, there's a solder bridge between. Now if we connect power, we should have 5 volts. This ground. Power. Show you the multimeter. Now we should have 5 volts, and now probably the other power supply also works. We don't have 5 volts. 5 volts. Yes. It's really this connector broken. So I think this will kind of end the stream. I see some mistakes. For example, this is one mistake. And actually prototyping is really inexpensive most of the way. So I think I've paid something like $6 for these. It's nothing. It's $6 is really not a lot. So I will increase the font here, so it's a lot more readable. I will, will I tent the wires? Will I tent the thing so I can increase the font? No, I will not tent them. Let's do it tented. Okay, just for the sake of having both things, so I can show you why tenting works. I will change all the vias, and there will be tented vias. So this way we can have nice solder screen. I will fix this. We can what we can do. I will not solder a microcontroller because I know that I only have one of these microcontrollers. They cost 11 euros per microcontroller, so they're expensive. I will not solder it to test it because I know that D plus and D minus are flipped. We could flip it here. I don't want to. What we can do though is test all the other things if they work. For example, the power rails. Now we can really connect, we can solder the LDOs and see if we have 303 volt in 1.8 volts. I will do that. We will not solder any of these. Seal screen. I like the green seal screen because the solder mask. It's really nice. Also, I need to fix this. Okay, we will do that. So I need 1 microfarad I need 1 microfarad. No, these are not the right one. These are the resistors. Yep. Top view and bottom view. Put all of these back together. Back in my USB breakout board. This is 5.1, this is 5.1, so they belong together. This is 5.1 also. Why do I have 2 of them? Okay. Up. This we don't need anymore. 100 microfarad we don't need anymore. They should be working. Actually, all I can test. Else I can test on these boards. This is too small. I will increase the logo. I will increase the font. I will put the seal screen for that. I will fix this, and let's for now try the power sources if they work, because this is all I can test without the microcontroller. All the rest I need the microcontroller. For all the rest I need a microcontroller. No, I know what I can do. No, let's keep it. Yeah, that's all I can do. So, do I have 1 microfarad, which is nano? What is this? 1 microfarad. This is 0.8, 0.5 large. They will not fit. Oh, 18 pico. 18 pico. I think I have a 12. Do I have 12 pico? 18 is fine also. I think this quartz crystal is meant for 12 picofarads. But I can do also, no, I'll keep it this way. Let's make just incremental changes. So what do we have here? 1 microfarad. This is 0603. Let's have 2 of them. Oh, 4. 1, 2, 3, 4. 2 for the inputs, 2 for the outputs. Rails. Up, up. Yeah. And when you solder, I'll need the multimeter afterwards. When you solder the first blob, try not to solder on the ground pad. On the capacitor, where you have a ground pad and a not ground pad. If you do on the ground pad, you will lose a lot of heat really quickly, and the solder will not stay warm for a long time. So try not to do that on the pad. And you see, the solder doesn't flow correctly on it because the pad is so large. This way I have a surface. I'm making a mess. Oh, under the camera it's easy. and here, which is 3.3 volt and which is 5 volts. The broken board, and we will not solder microcontroller on it. Important. With the correct way, make practice. So, which one is which one? I think U4. Let's have a look. U4 is 1.8 volts. So let's have up. Yeah, 1.8 volts. Other one 3.3 volts. Up. 8. 3. Let's put them and see if the power works. Then hold on one of the pins. Up there. And yeah, solder on the other. This part. Up. Part comes here. And the footprints are nice. Really like the dimensions of the really easy. Good as the could use the narrow version. Save some space, but I don't need one pin. Not really straight. Line correctly. Up. Access solder. And let's try if we have the power, if the rails work. So, where is our? We'll use again to see if we have a short. Connect. See, we have no shorts. Tiny bit of current because LDO, and if there's no current, well, it doesn't use currents. Wasting current of these devices is very small. Ground. Now, if we connect to 3.3 volts, we should. Yeah. 3.3 volts. This is 3.3 volts. Ground. 3.3 volts. Not good. This is 0.8 volts. We have 1.8. We don't have 3.3. What is wrong with the 3.3 volt outputs? This should be the output. But here, okay, we have no 5 volt on the input. Five volt. 5 volt. So there's 5 volt on the input. It's not the. I'll show you. Have a look at this part. Looks nice from the top. It was all not soldered. because there were some, this had, the second one had a tiny bit of solder, and it made that this didn't solder correctly. And this was, I didn't see it because I looked at the camera, and the camera only showed me the view above. Now I fixed it. Okay, don't solder on the camera. There's a lot of things you don't see. But this is also why we test. Here there should be 3.3 volt now. There is none. Should be 5 volts. There is 5 volts. 3 volts. Come on. Okay. The lead is soldered correctly. This one too, it doesn't look too nice, but it is soldered correctly. Why don't we have 3 volt output from this voltage regulator? Don't have 3 volt output. Five volt input. No output. And it's the same same regulator. Well, it's just probing. It is the same footprint, it's the same layout. Here we have 1.8 volts. It works, and here we don't have 3.3 volts. We know that we have 5 volt in. It means that the regulator is dead. I've used this regulator. Let's see. Oh, why it's not working? Let's get rid of the regulator. It is not warm. Oh, it is warm. Ah. And do we have, yeah, there's a power usage. Okay, so the power usage show that it is shorting. So something is wrong with the outputs, and it's not outputting because there's probably a short under this capacitor. Under this capacitor. Lot of solder. So let's check if there's a short under the capacitor. Zero ohm. There is the capacitor is dead, or there's a short under the capacitor. There's no visible short under the capacitor. Okay, we're in the mega ohm. The mega ohm is probably the output. It's probably because of the voltage regulator. Okay, and now if I plug in, we don't have a short. Now if I measure, not resistance I want to measure, it's voltage. 3.3 volt output. So this is fine. So yeah, I showed you how to debug also the power. There was something wrong, there was nothing output, the part was getting warm, you could touch it. You see on the meter that it was drawing a lot of current, and it was oscillating, so switching off after some time. And this is fixed, so the power works nice. And I didn't measure it on the output, but it should be fine. This is 5 volts. This, well, 5 volt V bus. So whatever is coming from USB, it is not regulated 5 volts. And this is also the output. USB. This is clearly indicated. Then we have 3.3 volts, right on spot, and then 1.8 volts, right on target. So the power supply works. So what I will do is try to figure out why SIGROC doesn't work, so I can use the multimeter. I will fix the footprint, I will increase the fonts, I will reorder PCBs and wait again 10 days or 2 weeks. I don't know what it won't. And then in 2 weeks we will continue soldering. We will resolder. And yeah, this is used for scrap. But c'est la vie. Okay, that was it. So I'll ping you once I receive other boards. And until then, enjoy the rest of the day.